现场所有的贵宾朋友们，大家午安，大家好，欢迎各位一同莅临 COMPUTEX 2执行长主题演讲。我是今天的主持人朱楚文，非常欢迎各位一同呢在今天下午来参与 ARM 执行长 Rene Haas 一起来了解运算的未来。Ladies and gentlemen, welcome to COMPUTEX ARM CEO Keynote Speech. It's my great pleasure to be your host today. I'm Ashley. Let's join ARM CEO Rene Haas to know more about the future of computing. 那在今天这个非常重要的时刻，我们很开心哦，可以邀请到重量级的嘉宾来到我们的当中。我们非常荣幸邀请到了中华民国外贸协会董事长黄志峰董事长来到现场了。那接下来呢，是不是让我们以热烈的掌声来欢迎黄董事长上台为我们说几句话？ First of all, let's welcome Mr. James Huang, the chairman of the Taiwan External Trade Development Council, to come out on the stage and give us some words. 欢迎黄董事长。
Well, ladies and gentlemen, good afternoon. I am delighted to welcome you all to COMPUTEX 2023 and a highly anticipated ARM CEO Keynote. And today, we had the pleasure of hosting our dear friend, Rene Haas. Rene is an old friend of Taiwan, an old friend of COMPUTEX. But this is his first appearance at COMPUTEX since he was appointed as CEO. And we are thrilled to have Rene with us in person, not online. As the world's leading semiconductor IP company, ARM is globally recognized for its cutting-edge technology that powers a vast variety of devices and applications. ARM's contribution to the industry has been immense and transformative. ARM and Taiwan share a long-standing history of collaboration. ARM's advanced technology and strong partnerships with Taiwan's foundries, IC design houses, OEM and ODM companies have been instrumental in innovation and growth of Taiwan's semiconductor industry. So we can't wait to hear the exciting news and updates that Rene will bring. So ladies and gentlemen, please join me in giving a warm welcome to Rene Haas, the CEO of ARM.
The world runs on ARM, where a tiny thing means everything. From town square to Times Square, ARM is defining the future of computing. A future built by one of the most successful technology ecosystems in the world. We fueled the smartphone revolution and will power every technology revolution moving forward. We are defining the next universal mobile experience and redefining what's possible in IoT and automotive, in cloud computing and the metaverse. A 30-year history of trust and security, and a legacy of energy and power efficiency brings hope for a sustainable future. We changed the world once. Now we have the chance to change it again. The future is built on ARM.
Ni hao. Wo shu Rene Haas. And James, thank you so much for a wonderful introduction. When you say I'm an old friend of Taiwan, I don't know exactly how to think about that, but I have been to Taiwan so many times. I think this is the, 17th COMPUTEX that I've participated in some level. My first one was 2006 in person. And now here we are live again in 2023. It is It's fantastic to be back. It's great to see such a full room of people and individuals. And I'm very excited today to talk to you about our company and where we're going and what the future looks like. To say the least, a lot has happened with ARM since we last saw you in 2019. And a little bit of fun, a little bit of drama, but we're very, very pleased to be here, independent, looking forward, and thrilled to be welcomed to Taiwan. So one of the stories that I get asked a lot about is, how did ARM get started? What is the genesis of the company? What is the DNA, the roots? And I think it's a fascinating story in terms of how the company initially got started, how our technology was born, and where we ended up and why we are what we are today. 30 plus years ago, there was an effort being done to create a brand new microprocessor. And at that time, the mobile revolution was just getting started. And one of the tasks that the ARM engineers, the early folks, in fact, even pre-ARM, had was to figure out how to design a microprocessor to fit into a plastic package. Now, this seems a little antiquated if we go back in time in terms of package technology, but 30 plus years ago, the state of the art for microprocessors was putting it into a ceramic package. And one of the tasks that the early architects had was to get the cost down, to get the power down. Let's figure out how to put this inside to a plastic package. And so they did. They created the very first ARM1, the very first CPU. They were able to fit it into a plastic package. And when they first began to measure the output current, and we're going back in time, so that instrument below is an oscilloscope. When they measured the power of that microprocessor, lo and behold, what they found out was it was running, but was drawing no current. It was actually operating off the leakage currents taking place on the rest of the circuit board. Pretty amazing, actually, when you look back in time. But therein, behold, was the birth of the ARM CPU. And I think that's very important to understand because the DNA of this company was born around power efficiency, running off a battery, not plugged into a wall. And when we think about going forward, where computing is going, the insatiable need for more and more performance, we don't have unlimited resources on this planet. So I think our forefathers at ARM were incredibly insightful and had a lot of foresight to develop such a product. Now, that first CPU went into one of the very earliest mobile products, for those who remember it, and I'm old enough to not only remember it, but I had one, was the very first Apple Newton, which was a PDA that was way, way ahead of its time. Handwriting recognition, didn't have a modem, kept a contact list, but the CPU inside that was ARM. And that is a bit of how we were born. So we are a company whose DNA was really built around power efficiency. And boy, 30 years later, what a ride it's been. It is now what we call the world's most pervasive computer architecture. Our first 10 years, between our silicon partners, over 1 billion chips were shipped using ARM. But that was just the beginning. In the next 12 years, up to 2013, we went from 1 billion to 50 billion, a huge astronomical growth. And it's really just accelerated from there. The next number of years, we got to 200 billion cumulative, and we're now looking at, since the inception of ARM, over 250 billion chips have been shipped using the ARM architecture. There's no other computer architecture that's ever been invented that's even close to this number. And that has a lot of benefits for the ecosystem. It has a lot of benefits for developers. But most of all, it has a lot of benefits for users to have such a broad architecture with such amazing support. Now, going back to the Newton, what drove a lot of this growth probably 5 to 10 years ago was the ascent of the smartphone. And when we saw the smartphone start to grow, that's what really fueled ARM's growth. I think that story is well known. But as we advance into new markets, what we start to see is a lot of products begin to resemble the smartphone. High compute, complex software needs to run off a battery. And now what we are seeing is across the board an insatiable demand for compute resources, whether it's data centers, whether it's automotive, and obviously around the areas of our artificial intelligence, which have had incredible buzz over the last number of years, and now even over the last number of months, given everything going on with generative AI. The need for compute resources is insatiable. I remember coming to a COMPUTEX, I don't know, maybe it was 2009, 2010, and this was just after the financial crisis. And at that time, we were starting to work on tablets and things of that nature, but there was a general feeling of, gosh, what's the new killer app? What's going to be new beyond tablets? Because people were starting to run out of ideas whether there was going to be every need for compute resources. And my gosh, 10 years later, how wrong were we? Because the digitization of our lives has changed everything. And the needs for compute, they're going up beyond our imagination. In the data center, you look at the growth, 260% over the last number of years. But equally, you have these data centers now consuming a significant amount of energy. 1%, depending on where you look at the numbers, in other countries it's larger than that. And that is obviously a huge concern in terms of what do we do around sustainability. In autonomous, whether we're talking about robotics or autonomous vehicles or anything that runs off a brain system, the level of TOPS required for these autonomous systems continue to increase. Up to 4,000 TOPS required for level 5. And as we move more and more to vehicles that are EV, you want to use as many of those resources for the battery that moves the vehicle. So this computer on wheels that needs to be able to have a huge amount of compute capability needs to be sustainable. And then when you get into AI, my goodness, the models are just exploding relative to what is required to run some of these operations. And it's only going to get more and more complex. More and more training will drive more and more inference, which drives more and more training, which drives more and more inference. All of that is going to require computing resources like we've never seen before and require a sustainability picture. So in terms of demand for computing resources, and as we've mentioned before, I'm an old friend of Taiwan, I'm an old person in this industry, I've never seen it like this. Honestly, I think we are in a golden age now in terms of computing and what's required to change our lives. It's amazing. Now, that being said, there are certainly some challenges relative to how to solve this. Scaling and building chips is becoming more and more complicated. Moore's Law, Gordon Moore, one of the icons of our industry who just passed this last year, his famous axiom in terms of the doubling of transistors happening every couple of years, increasing computing performance, is coming up against a wall. We know that. As transistors get smaller and smaller, the needs for design becomes more and more complex. And with that, these complex AI systems require innovative design. How to solve this problem? It is a very, very tricky problem in terms of the technology nodes, the processing, what needs to take place. Now, the cost and complexity of these designs has just gone up massively over the last number of years. If you look at 7 nanometer going north to the advanced geometries, you can see what the numbers look like in terms of the cost associated with this. There's no mystery that this is the technology and sport of kings. It takes a tremendous capital investment to be able to build these complex semiconductors. And at the same time, when you start going to narrower and narrower geometries, these are the most valuable transistors on the planet. These transistors need to be used for the most important tasks, which is essentially the compute, and that's where it needs to get done on the advanced nodes. So we're having a tremendous amount of tension relative to solving this problem. Additionally, a lot of the cost goes into this is around software development and verification. So even when people start talking about, oh, ChatGPT is going to design the next level of circuitry, not so fast. This is incredibly complex work. And at the same time, it's a heavy load. And these are some huge, huge issues for the industry. These designs are getting harder and harder. In Taiwan, we're in the land of the world's most advanced semiconductor fab on the planet, where TSMC lives. Everything is getting more and more complicated relative to building these chips. The compute complexity that I talked about earlier, you need more and more transistors to solve it. But yet the cycle times for building these products is getting shorter and shorter in terms of you need to develop a product in a year, a smartphone needs to come out every year, yet the cycle times in terms of getting process nodes to deliver these products is getting longer. So this is a big conundrum. And AI only compounds this problem in that these designs get more and more complex. So, is this an unsolvable problem? Are we looking at a fork in the road relative to where products are going? We actually believe that we are on the cusp of something very, very innovative, but at the same time, potentially have seen this movie before, around building systems on chip. So, again, I started my career 500 years ago when a motherboard had a north bridge, a south bridge, a memory controller, all kinds of different components, and all these components shrunk into an SoC. And as they shrunk into an SoC, you had scaling benefits, you had cost benefits, you had time to market benefits, and then there were many companies that went away. There were a lot of companies who were building a lot of the core logic around PC chipsets, other areas on a motherboard, and they all started to fall away as everything went onto a system on chip. But now the system on a chip is starting to bump up against a wall. So what happens when all this integration starts to bump up against a wall? Well, just like fashion, where things tend to come back that didn't look fashionable years ago, but now they are some years ago, the SoC is disaggregating. And the substrate becomes the motherboard. And the motherboard is now housing all these complex chips. So one of the immediate benefits of this is you can start to apply some of the most expensive transistors on the planet to do compute with the advanced nodes. But other areas of the chip, communications, let's say, or some of the I/O, or things that may not iterate as fast as other technologies, you don't have to potentially use those very, very expensive 3 nanometer and 2 nanometer transistors. And that is a huge inflection point that people have talked about, but it's now real. It's now moving to a reality in terms of where systems are going. And at ARM, we have embraced this. So we have been traditionally an IP supplier, and as an IP supplier, we develop a configuration, we work with our partners, and they take our IP, they integrate it with their sets of IP. And over the last couple of years, given the issue I just talked about, we started to see tension with this, in that it was just taking longer and longer for our IP to be integrated with other IP than to be developed into an SoC. So we have moved into what we call subsystems. And the benefit of these subsystems is we take the products that we build, the CPU, let's say, the memory subsystem, the compute block, and we integrate it, we configure it, we validate it, and we can deliver a full subsystem design. And the benefits, as you can imagine, are very significant in terms of the end user because of all the issues relative to how hard it is to develop products. But this is real. This is not a concept. We've rolled this out to a few different customers, and we've seen significant benefits already. We have seen one customer from the time we did a kickoff till the time they did a tape out, 13 months. What used to be multiple years has been shaved down. And this is massively beneficial in terms of getting products out, getting customers happy, delivering solutions. Additionally, it's a huge, huge resource benefit. In one case, over 80 man-years saved. Now, these aren't jobs that go away. These are man-years that can be used for other pieces of work, but it is a significant benefit to the end customer and to the markets. And again, this is largely driven by the fact that we have reached a new paradigm relative to how difficult it is to build chips. They are just so complicated. They are so innovative. And AI, which continues to drive even more and more innovation, adds this. Now, a very interesting example I'd like to share with you that I think was probably talked about a few hours ago at NVIDIA's keynote is no coincidence here. His was first, mine is second. This is an example of how these subsystems can be used. So NVIDIA has developed a product called Grace, which is a CPU. It's what they call a super chip. Underneath the hood, when you peel it back, you have 2 blocks of Neoverse, which is our product line for the data center. 2 blocks of 72 different cores on one sub-die, total of 144. Now, this gives an incredible amount of capability relative to performance per watt, if you just look at the numbers there. We are well known for our efficiency, if you go back to the birth of the company. And it's really important to recognize that, because when the DNA of the company is all about power efficiency, when the DNA of the company is all about thinking about how to run off battery, that's hardwired into how the engineers think. So I've got lots of questions since I took over as CEO about why is ARM winning in the data center, and why is ARM winning in autonomous, and what's so significant? What have you done differently? It's a combination, obviously, of product development, but it's also a combination of just innate to the products is a sensibility about efficiency, which is incredibly important. So we were thrilled to partner with NVIDIA on such a product, which Jensen talked about earlier today. And when you combine that CPU complex with the GPU complex, you have an incredible, innovative AI engine. But this is really just an example of what I talked about earlier. This is a real-life example of where scaling is an issue, where time to market is an issue, where complex sub-blocks need to be integrated and delivered, and here you see the real instantiation of it. And it's going to be a very, very significant product, we think, going forward in terms of AI, but as you can imagine, there are lots of different examples to talk about. Now, as you've probably seen in the press, we are in a quiet period, so I would love to talk to you about all kinds of different things that are coming down the pipe, but there's so many cameras in this room that I am afraid to go much further. But since NVIDIA talked about this earlier today, this was one of the ones we could talk about. And there's a real end application for this that is hugely exciting. And one is really around an edge data center that can be a virtual RAN network and at the same time be a generative AI engine. So think about here the concept of taking a single block computer and with that being able to provide a industry standard block that looks a bit like a server, can run industry standard software, will basically run all the Linux stacks, et cetera, but at the same time can do generative AI. So this is just one small example of something that is going to be moving forward. You can see that this is a triangle of ourselves with NVIDIA, and this is a concept now that SoftBank is moving forward with. Now, the area that we are really also thrilled about in terms of where things are going with the data center is the fact that as you do generative AI and you do it inside the data center, all of the CUDA stacks, CUDA being the proprietary language that NVIDIA uses for programming their GPUs, those stacks all run on the ARM CPU. So what that basically means from a top level, developers can now develop their code, they can generate their models, and through the stack and through everything that kind of runs through the entire software suite, can decide whether that runs on the ARM CPU or the GPU. So the bottom line is when you're running AI, AI is going to run great on ARM. Now that's an application that is very significant in the data center. But actually, one of the things I am very excited about is the endpoints. So all of this training that takes place in the data center around generative AI needs to run somewhere, right? The connection is, well, if you're training, it's got to be able to connect to something on the other end. And that's where I actually think the gigantic opportunity is, and it's at the endpoints. And we are seeing an explosion for AI at endpoints. And this is a virtuous cycle where the more intelligent the models get, the more work that gets done in the cloud. That's going to drive need for AI inference at the edge. And what is required at the edge for these complex AI algorithms? You need A, a lot of compute, and B, you need power efficiency. That's a given. And we have a huge scalable solution that can run the gamut relative to the overall software stack. We have M-class at the very bottom. We move forward to our smaller A-class, and then up to our A-class and Mali GPUs. So we have been working on this for a number of years. And again, as we've seen this opportunity now just exploding relative to all the AI algorithms that are going to be required at the edge, we've delivered many of these solutions to partners already. We have these in the marketplace, and this is driving significant opportunity for the company going forward. But it's not just a product roadmap. There are lots of real examples and applications where it's taking place today. You know, one is the Google Pixel 7, which does live translate, it does live caption, it's a virtual assistant. I don't know if you've ever played with this product, but through the Tensor engine, working with the ARM Cortex-X1, which has multiple CPU blocks and GPU, this product will be able to do a number of different innovations relative to translating what you're talking about, whether it can make predictive analysis on captions, and all of that is AI at the edge. That is essentially all those workloads that are now running locally that were trained on the cloud that have to run in the palm of your hand. And oh, by the way, it can't consume any more power. And that is the virtuous need that takes place with these products. Amazon Echo. So Amazon Echo uses a product from Amlogic. The Echo that will essentially do all the voice commands relative to translations, ordering, anything that you want to do relative to your interaction with Amazon, all of that takes place with Amazon Echo. And that's all running off the Amlogic CPU, running on ARM, and provides an incredible experience relative to an AI background. And again, this might not be something that you might think is AI, but it is AI. Because it's taking commands and learning and training based upon what your voice is telling it, and at the same time, it does learning. One of the really cool examples, and this is actually done on an M-class product, this is an intelligent traffic monitoring system. Now, it actually embeds into traffic lights. So what the lights are able to do is, based upon learning, based upon patterns of traffic, are actually able to modulate traffic lights. So this is done in Korea. And by the way, I've always noticed in Taiwan, your traffic lights are really long. I'm not sure why they are, but you have the longest traffic lights I've ever seen in the world. Hopefully AI can find its way to your 90-second signals at some point in time. Because what this product does is, on a real-time basis, will modulate the lights. And it will do it not just based upon a previous day or a previous week, but it's doing real-time active monitoring. And you can imagine, in the past, you say, does a traffic light need a CPU? Gosh, I didn't know that. Yes, I guess it does. But now it's going to need a CPU that is intelligent, that can actually run algorithms based upon training that's done. And the training can be done in the cloud each night, and it can send information back down to the lights. Very real-time example. And again, needs to be very power efficient because you're not adding anything new relative to the electronic subsystem, but it's a very real application of where we see growth. Another fairly cool example that you would not think intuitively is an AI piece is a smart appliance. And again, what would AI have to do with a smart refrigerator? Well, when you think about the life cycle of the compressors and the life cycle of everything involved with the subsystem, having some level of AI involved that can monitor, track, and reduce power is a huge issue. So this company, which I think is based in, I'm going to say Czech Republic or Turkey, but I'm probably going to mix it up. They've had an interesting innovation here where they've embedded ARM technology doing AI around compressors. So this is not your mindset of a refrigerator that has a display and you talk to it and it makes ice for you. This is a real live example of saving power, saving energy, which is one of the areas that, as we think about what's required for the planet, is really significant. And lastly, one that I didn't know about until we started talking about different examples as we were getting ready for Taiwan. This one I think is really fascinating. So first off, you probably weren't aware that the bee population has been decreasing by about 30% a year. Yeah, who knew? I had no idea, but that is a true fact. And bees are incredibly important to the world's ecosystem. And the way that people in the industry who are beekeepers, who manage and run bee farms, is very hands-on. The folks go out to the trays, they go out to the hives, they monitor what's going on by hand, and then they come back and try to make the fixes. There's a company called Beeswise, and I would recommend you Google this and take a look at their video online afterwards. They have an amazing technology that is now completely gone to automation. There are robotics involved in terms of changing out slots. There's robotics involved in terms of monitoring the health of the bees. And there's a huge amount of work that's going on relative to the health, the life cycle, the feeding. And guess what? This is all based on ARM. It's a combination of ARM technology, Raspberry Pi, and also some work that was done with NVIDIA. But the point being is that when we think about everything going on with AI and everything going on that we think about generative models and gets a lot of hype, there's a fantastic amount of examples that will be very real for us, that will help our communities, they'll help our planet. They need a high level of compute, and they need power efficiency. And that's a great place for us. Now, none of this can happen without software and a software developer ecosystem that drives the application. And I've been, again, in this industry my whole career. I've been around lots of CPUs. I've worked with a lot of CPUs that are now in the CPU graveyard. I've worked for a few companies that are in that graveyard. The value and power of a CPU comes down to its software. It comes down to developers, it comes down to software ecosystem, it comes down to people who are writing code for that software. But it is a virtuous loop relative to the more developers that are working on your platform create more hardware. More hardware lends credence for more applications, which lends credence for more people writing software. And there is no software ecosystem on the planet that's even close to what ARM has shared. And that comes from 30 plus years of working across broad number of areas, broad number of developments. And we've just seen this accelerate over the last number of years. You can look at the number of developer hours that has been spent on our version 9 compared to version 8. We've had a huge increase. You look at the number of developers who write software on ARM, it's a number unlike any other. And this is needed to develop great products. It's needed to get great products to market sooner. Because in this world of insatiable demand for compute resources, and the fact that it takes longer and longer to build these systems, software is everything. And we're very, very pleased to be able to say that the developer community has been so strong, and so much thanks to all the folks who develop on the ARM platform. We are at an amazing time, really, in our industry, and I can see by the number of folks who are in the room attending. Obviously, there's a huge amount of interest with all things going on with our technology and compute. As I said, I have never seen a time, quite like it relative to our industry. So much so that when I think about predicting the next 5 years in terms of what is going to be required from a technology landscape, it's pretty hard to think about and imagine what the next generation of products are going to look like. But I think we do know a few things. They're going to be extremely compute intensive. AI is going to be everywhere, and they're going to get harder and harder to build. But for that reason, we think that the future of computing is built on ARM. Because everything now is a computer. Your toaster is a computer. Your car is a computer. Your Nespresso machine is a computer. And building those computers is getting harder and harder and harder. And when you layer AI on top of it, my gosh, there's a lot of work to do. But I'm very, very confident that ARM, together with a developer community like no other, and we have fantastic partners here in Taiwan we've been working with for decades, who I thank deeply for everything that you've done for us. The future could never be brighter. And it's been an interesting number of last few years for ARM, but I am personally very happy to be standing on stage with you back at COMPUTEX. I think the future for our industry and ARM has never been brighter. Thank you so much.
Thank you, Renee, for the wonderful speech. Thank you, and please remain on the stage because we're going to take a group photo. It's time for a group photo. 接下来呢，我们要来一个大合影哦。我们再一次欢迎中华民国外贸协会黄志芳董事长上台，来一起和 Renee 来合影留念。Let's welcome James to come on the stage and take a group photo with Renee. 是不是让我们再以热烈的掌声来谢谢刚刚 Renee 带来精彩的演讲，以及黄董事长非常精彩的致辞。Okay, let's look straight to the media. Yes, a big thumbs up and a big smile. Thank you. 谢谢非常多的这个贵宾朋友，今天呢特别来到我们的当中。好，谢谢。Okay, thank you. Thank you for your attendance. 好，还有很多贵宾朋友在拍照哈。好，非常谢谢大家的参与。Thank you, Renee, and thank you, James. Thank you for coming. Thank you for being here. And please return to your seat. 哇，今天呢 Renee 精彩的分享，我想都让大家对于运算的未来呢有了更多的想象哦。在未来呢，真的是我们的科技生活将有完全不同的改变。那非常谢谢大家今天一同来参与 COMPUTEX ARM 执行长的主题演讲，相信呢大家应该都收获满满了。那我们今天呢这主题演讲就在这边告一个段落了，谢谢大家的参与。那在最后呢，也再一次跟大家来预告一下，我们在后天5月31号的上午 ，ARM 资深副总裁暨基础设施事业部总经理 Mohammed Awad 将会参加晶片与半导体先进技术峰会，同时也会发表演讲，主题是 Freedom to Innovate the ARM Neoverse Advantage， 会和其他的与谈人一起来畅谈这个运算的未来，欢迎大家可以踊跃报名参与哦。那同时呢，大家在离开之前也别忘了要归还口译相关的设备哦，拿回您的证件哦，大家一定要记得喽。谢谢大家，那我们就下次再会喽。We are pleased to announce that in the morning of May 31st, Mohammed Awad, Senior President and General Manager, Infrastructure Line of Business of ARM, will participate in the Chips and Semiconductor Summit, the next big leap in computing, and deliver a keynote speech. The speech titled is Freedom to Innovate, the ARM Neoverse Advantage. He will then join other speakers to discuss the future of computing. We welcome everyone to register and join us. And don't forget to return the interpretation devices before leaving. Thank you for your coming today.